All right, good afternoon, everybody. We're going to make a video with lesson 2 of unit 7. This is going to be on solving trig equations, and there's going to be a couple different types of equations that we look at, but I just wanted to point out that this form, right, essentially something with a single trig equation or a trig function in there, that's going to be the main emphasis for today. So even though you're going to see a couple tricky equations, this is the form to focus on for today. All right, let's get on with it. So first couple examples, right? 3 of them. We want to solve these equations for theta in this range. Okay, so we're in radians and we're looking at one full rotation around the unit circle, right? And we've got sine squared, we've got sine 2 theta, and this one's a little bit trickier because we have sine and cosine. All right. So with this first one, what we want to do is basically isolate the trig part. So in this case, we want to isolate sine theta. In this case, we've got sine 2 theta already isolated. Here, we're going to have to do some work because we've got a sine and a cosine. In part A, I'm going to rewrite this as sine squared theta equals a half, right? So that's just basic algebra. To isolate sine theta, I need to take the square root of both sides. So this means that sine of theta could equal plus or minus the square root of a half. Okay, and really, if we think about that, that's plus or minus 1 over root 2, which is the same thing as plus or minus root 2 over 2. Okay? We should have light bulbs going off in our brain. This is a unit circle value. So we want to think about what are the places where sine theta equals plus or minus root 2 over 2. Well, that's all 4 quadrants, right? We've got 2 places here. This is root 2 over 2. This is root 2 over 2. And we've got 2 places here. Here the sine of this angle is negative root 2 over 2. Same thing here. So it's pi over 4, right? Pi over 4 is this first location. And we're going to run everything off that. So theta could be pi over 4. That is this value right here. It could be 3 pi over 4, which is here. 3 pi over 4. It could be 5 pi over 4, which is here. And 7 pi over 4, which is here. So those are our 4 answers. 5 pi over 4, 7 pi over 4. And let's just underline this there, okay? So it's a little bit tricky because we have sine squared equals a half, and we have to remember to take plus or minus of that. Second equation, very similar in that it's sine, but we've got 2 theta in here, and we just have positive a half, okay? So I'm going to write a general solution to this, right? So I know from kind of the above, well, let's say this. Let's say that u is equal to 2 theta. The sine of u is a half if u is pi over 6 plus or minus 2 pi k. So that's in quadrant 1. Or u is equal to 5 pi over 6 plus or minus 2 pi k. That's in quadrant 2. But u is equal to 2 theta. So if I want to solve this for theta, I'm going to divide by 2. Right? Let me explain what I mean. So u, that's really 2 theta. So these 2 expressions, this and this, are equal to 2 theta. If I want to isolate theta, I have to divide all this by 2. Okay, the whole expression. So that means that theta is equal to pi over 12 plus or minus pi k. Or theta is equal to 5 pi over 12 plus or minus pi k. And k is any integer. All right? We want values only for this, between 0 and 2 pi. So I'm going to start with these 2 values, and I'm going to add or subtract pi until I get numbers that are outside this range. So let's go to blue here. So this first part, right, that really means that theta is equal to pi over 12. Pi is the same thing as 12 pi over 12. So that's, if I add that, I get 13 pi over 12. If I add 12 pi again, I'm at 25 pi over 12, and I'm outside of this range. So I get two answers here. It's going to be similar for the second part of the solution. So we can also say that theta is equal to 5 pi over 12 and also 17 pi over 12. So hope that made sense, but we've got actually 4 answers there. Keep in mind we could subtract pi. If I subtract pi from pi over 12, I have negative values. That's outside this range. If I subtract pi from 5 pi over 12, I'm also outside this range. Okay, but this is really nice because this is called a general solution. This is all the possibilities that solve the equation. This is called the particular solution. So in this case, we just want values that are inside this range. So we get 4 answers. Okay, last one. Well, I'm going to rewrite this. I want to get rid of the sine, the cosine, so I'm going to rewrite it as tangent. So another way to write this equation is that tan theta is equal to a half. Right? So if I take sine, I divide by cosine over there, I get tangent. I want to get rid of this 2, so dividing by cosine gives me a 1. When I divide by 2, I get the half. Okay, and we also want to say, because now I'm dividing by cosine, we should be careful that cosine theta can't be 0, which means theta can't be, where would that be 0? Pi over 2, 3 pi over 2, dot, 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 dot. So when is tan equal to a half? That, I'm actually not sure if that's a unit circle angle. This is a little bit embarrassing. Let's look it up. Tan x equals a half. Yeah, okay, it's a non-unit circle angle. So to solve this, let's take the tan inverse of both sides. Right, so we could say that tan -1 of tan theta equals tan -1 of a half. So theta equals, if I input this into the calculator, give me 1 second, let's see what we get there. And I gotta be in radians now. So let's change this to radians. Arctan of 1/2, and that's 0.464 about. So theta equals 0.464 plus or minus pi k. Well, why am I doing this? Well, if we remember the period of the tangent graph right here, the period of the tangent graph is pi. So if this is one value, I can add or subtract pi k and be at the same location and therefore get the same tangent value. Sorry, not the same location. Yeah, the same location, different angle. All right. So I can add pi once. That would be theta equals 0.464. That's the original. 0.464 plus pi. So let's take that. And let's add pi. That's 3.605, which is bigger than pi. If I add pi again, I'm going to be outside of 2 pi. So these are the two angles that we want. And one is in quadrant 1, where both are positive, and one is in quadrant 3, where both are negative. Okay, so the sine and cosine values are equal. Just need to just need to underline that. All right. So next, find the general solutions. In some ways, these are easier because we can just take our angles and we can add on the periods. All right, so I actually prefer these more in a lot of ways than particular solutions. Cosecant. So if we remember, this is the same as 1 over sine theta minus 30 degrees, so we're in degrees now, is equal to 1. So that's really the same thing as saying sine of theta minus 30 degrees is also equal to 1. So where is sine equal to 1? Well, it's at pi over 2, right? 90 degrees. So this really means that theta minus 30 degrees is equal to 90 degrees. Okay, because the sine of 90 is 1, so I'm setting this part, which is at, equal to 90. And there's nowhere else on the unit circle. So, but I've got to think about the periodic nature of it. So I'm going to add 360 degrees times k, right? So this part is saying, well, you start at 90, you go some positive or negative multiple of 360, you're at the same place. Okay, so this is the general solution for theta minus 30 degrees. To solve for theta, we just need to move the 30 over. So theta is going to equal 120 degrees plus or minus 360 degrees times k. So that is our general solution. This gives all the values, right, where the cosecant of theta minus 30 is 1. All right, same idea here. So I want to isolate this and have sine of this stuff is equal to something. And I think there's a little bit of a trick here. We'll see though. So we got sine of 2 theta minus 60 degrees is equal to 4 over 3. Now this is a problem, right? The problem is we know the sine of any angle is equal to 1 maximum. So this can't happen, right? So this is a trick. There's no angle that you can take the sine of and get 4 over 3. If there was a number in front of this, it'd be different. But so this guy is theta equals no solution. Or I guess, you know what, we don't even need theta equals no solution. That's kind of overkill. So there are no theta values that solve that equation. And sorry guys, I just realized that was a trick. I'm not dividing, I gotta subtract, right? So let's take this back. If I want to isolate the sine, I gotta subtract 3. So glad I caught that, because I know you guys would have. This is the same thing as sine of 2 theta minus 60 degrees is 1. So again, same location, right? We want the sine to be 1, so that occurs at 90 degrees. So we're going to set this equal to 90 and then add in the period. So 2 theta minus 60 degrees is equal to 90 plus or minus 360 degrees times k. All right, I'm going to move the 60 over, and then I'm going to divide by theta. So this means that 2 theta is equal to 150 degrees plus or minus 360k. Right, again, that's just taking the 60, moving it over to get 150. And now when I divide by 2, I got to be careful. I got to divide both parts there, right? If I add 60 to one thing, it's okay. I don't have to distribute the addition. But here, if we divide, we got to divide everything in the equation by that number. So that has to be true for this whole thing. So theta is going to equal 75 degrees plus or minus 180 degrees times k. So there's our solution, not no solution like I said earlier. All right, these are repeats, so I crossed these out before, the bottom ones, so hopefully it won't be too confusing. I'm just going to work and take this, solve it here, take this, solve it here. Maybe I should write in C below, and C below. And these are still general solutions. All right, this equation is really tricky, right? Because we have cosine, but we have two different arguments. So we're going to use an identity here that I don't know if we've learned. I don't think we have actually. But cos 2x is the same thing as cos squared x minus sine squared x. Okay, so we'll learn that, but I'm going to rewrite this in that way first. So cos x equals cos squared x minus sine squared x. Now this is a little bit better, but ideally my equation just has one trig function. So I have cosine here, I have cosine here, I have sine here. I want to get rid of that. There's an identity that actually I think you guys maybe learned last year. It's the Pythagorean, right? So we know that sine squared x plus cosine squared x is equal to 1. So if I solve for sine squared, it's 1 minus cosine squared. So this is 1 minus cosine squared x. And then what that turns into is 2 cosine squared x minus 1, right? So I've got cosine squared. I'm subtracting a negative cosine squared, so I've got 2. I've got cosine squared minus 1, that. Okay, so a new equation is cosine squared equals 2 cosine squared x minus 1. This is going to be a quadratic, right? I can make u cosine. So really this is the same thing as 0 equals 2u squared minus u minus 1. And this is letting u be cosine x. That sounds a little bit weird. U be cosine. Okay, does this factor? Yeah, hopefully. Let's see, 2u, u, yeah, that. So really, now I can set each part equal to 0. So this means that 2 cosine x equals negative 1. So cos x equals negative a half. That's solvable. That's a unit circle angle. Here, this is saying cosine x equals 1. That's also solvable. And we just want general solutions. All right, so negative a half, that's in either quadrant 2 or quadrant 3. So x can be, what would that be? 2 pi over 3. Yeah. 2 pi over 3 plus or minus 2 pi k, or 4 pi over 3 plus or minus 2 pi k. So got some solutions there. Cosine x being 1, well, that's at 0 plus or minus 2 pi k. So this is x is 0 plus or minus 2 pi k. So wow, we've got a lot of different solutions to this. Here's one. Here's a second. Here's a third. Okay, coming over to this top right one. I didn't want to do that. So we got cosine here and here. Okay, I'm going to divide by cosine. Actually, I'm not going to do that. I'm going to factor because I'm going to show you why that's a better thing to do. So let's rewrite this as 2 cos theta sine theta minus cos theta equals 0. Okay, I'm going to factor the cosine out. All right, what's going to happen sometimes is people might say, oh, I've got cosine and cosine. Divide both sides by cosine, and you'll get a more simple equation. You'll get 2 sine theta equals 1, which is the same as this. But when you divide, sometimes you forget that, well, hey, if cosine theta is 0, this side's going to be 0, this side's going to be 0. So that's also a solution. So my preference is move it over and factor, because now we've got both those equations. Here's cosine theta is 0, right? That would be the same thing as realizing, hey, if I divide, I got to include that possibility. And 2 sine theta equals 1. That's right here, right? Because this is 2 sine theta minus 1 is 0. If I move this minus 1 over, it's the same thing as 2 sine theta is 1. Okay. So here, when is cosine equal to 0? Well, that's at pi over 2 or 3 pi over 2. So theta could be pi over 2. I could do plus or minus 2 pi k, but I'm just going to do this, plus or minus pi k, right? Because if I take pi over 2 and I add pi, I get 3 pi over 2. If I take 3 pi over 2 and I add pi, I get 5 pi over 2. So this is a more simplistic form than writing two separate equations. All right. I know I'm kind of going pretty fast through this, but just, you know, ask your teacher if there are questions. That's one solution. Sine theta equals 1/2. So when is sine theta equal to 1/2? Well, that's in quadrant 1 or quadrant 2. So that means this one I have to write separately. Theta could be pi over 6 plus or minus 2 pi k. Or it could be 5 pi over 6 plus or minus 2 pi k. So 3 answers, messy handwriting, but those are the solutions to this equation. Guys, by the way, you know this, but you can check all these with Desmos, right? So just graph them, see if what I'm getting generally is the correct answer. All right, third one. Now, actually, this one, if we look, this is very similar to what we had. Where is it? Here, right? After I subbed in the u's. So this is also going to be a substitution with u. It's a quadratic form. I'm going to do this in a different color than blue because I don't want it to get confusing. So we'll do this over here. If u is equal to sine x, then this becomes 2u squared minus u minus 1 is 0. Wow, that is the exact same thing, I believe, as what we had in the cosine. Okay, so this factors is 2u, u minus 1 plus 1 is 0. Okay, and this is sine x equals negative 1/2, and sine x is 1. So x is, since it's a general solution, I can write it any way I want. First place, this is quadrants 3 or 4, negative 1/2, so I'm actually going to say negative pi over 6 plus or minus 2 pi k. That's in quadrant 4. And then the other one's going to be 7 pi over 6. That's in quadrant 3. So 7 pi over 6 plus or minus 2 pi k. So guys, you're seeing that unit circle is really, really important in solving these. Okay, so 2 answers there. When is sine x equal to 1? Well, that's at pi over 2. So x equals pi over 2 plus or minus 2 pi k. All right. I was just going to stop the video, but I just realized, hey, that's it. So you've got some more practice here. We're going to put a worksheet up, and the homework this time is all out of Haste Math, right? Which is the IB book. Okay. So hope that was useful. As always, you know, write your teachers. Ideally, write each other using the questions document if you have questions and you want them answered. All right, guys, enjoy.